Okay, so now we have this function that says 5 secant squared theta, here's our theta, times tangent cubed theta dx. So then we have to figure out, well, we know the derivative of secant is secant tangent. So this is the y, this is the y prime. But that doesn't work out because that's a tangent cubed. So a good idea to start to figure out what the u is going to be is look at if one of these trig functions have a higher power, then that's the indication. Oops, I'm going to put that in blue. That's the indication that tangent theta is going to be our u, and then our du, the derivative of tangent is secant squared theta times the derivative of theta, which is 5. So I'll just put the 5 front dx. So this whole thing right here, 5 secant squared 5x dx, we can now replace all of that with du. And then what we have left is u cubed. So now what we have left is u cubed du, because here's our u, and this stuff right here is being raised to the third power. All right, so then, and this should be written, close to it like that. So to unwind this u cubed, you're going to add 1 to 3. You're going to divide that number by 4. Put plus 0, because the antiderivative of 0 is the constant c. And then inside here, so that's what we have. So it is, well, and the way that you can write this, it's more commonly seen, would be written like that. Now, to check this, you would take the derivative of tangent to the fourth 5x divided by 4. So that would be a chain rule. Now, the outside function is something to the fourth power divided by 4. So the very outside function is this. So we're first going to take and then inside here is tangent 5x. All right, so we're going to take the derivative. So this is what, so the 4 will come down in front, and then that will leave a 3. Okay, so now what we have is y prime is tangent cubed 5x. Okay, well, the cube part has been taken care of, right? This has all been taken care of. So now we have to, we're going to take, this will be our g, and this will be our h. So now we have to take the derivative of tangent. Derivative of tangent is secant squared theta, and then the derivative of theta is 5. And look at what we have when we finish it. It is 5 times secant squared theta times tangent cubed theta. Yeah, and that's what we originally started with. So that is one way that you can do that check, is if you've untangled it. So I'll put on here, this is the check. Okay, let's find another, see if there's another trig one. Right there. Okay, we'll go up and do those in just a second. All right, so what we have here is cosine theta. I believe that is going to be our u. Well, actually, our u is going to be 4x to the fourth plus 5. Our du is going to be 16x cubed dx. Well, here's the dilemma. So this right here was our u. Problem is, we have a 64x cubed. This is only 16x cubed, so we're going to have to multiply both sides by 4. And now what we have is 4 times du is equal to 64x cubed dx. And this thing right here matches with this. So what that means is there's going to be a multiplier outside here. This 4 right here comes outside here. And then what we have left is cosine of u. du. All right. And the antiderivative, remember our list. Here's y prime. The derivative of sine is cosine. So working backwards, so f of x would be, we'd have the multiplier, and then working backwards from cosine, well, this is cosine u, so that would be sine u. I'm going to leave some more space. Sine u plus 0, and then working backwards from 0, we get a constant. And where u was, we now put that original. Just like that. And then if you want, do the check, take the derivative. So the derivative of sine, so you've got 4 times, remember the 4 is just a multiplier, so the derivative of sine is cosine. And then the chain rule, the derivative of the theta is 16x cubed, but when you multiply 16x cubed times 4, you get 64x cubed cosine theta. And that is what it started off being. All right, let's do, I'm going to go ahead and erase this. Now this is a dilemma. Remember when we've got our trig functions, negative sign, working backwards. So the derivative of cosine is negative sign. So eventually we're going to have to put a multiplier, a negative multiplier out here. But let's go ahead and determine what the u is. Here's our u. So our u, our u is 4x to the fifth plus 1. Our du is 20x to the fourth dx, but it should say 40, and this should say a negative 1. So what we're going to do is we're going to multiply so what we have is negative 2 du is equal to negative, let me think about this. We want that to say 40. Okay. So we don't have to worry about the negative sign here, but because the derivative of cosine is negative sign, if sine is positive, then that means when you work backwards, the antiderivative, the answer there will be a negative in the answer. All right, so now we can just say, okay, this is supposed to say 40x to the fourth dx, and right now it only says 20x. So we're going to have to multiply both sides by 2, and now we have 2 du is equal to 40x to the fourth dx. Boom. And now what we have left is sine u. So we have, a 2 up front, and then sine u du. All right. Now remember, the derivative of cosine is negative sine. So if we have a positive sign working backwards, that's going to be a negative cosine. So this is going to be 2 times negative cosine u plus 0. And then working backwards from 0 is the constant. So this is negative 2 cosine, and where u was, we put 4x to the 5th plus 1 plus the uppercase c. Just like that.